Welcome.
Hi, everyone.
First of all, tell us about your work and your dream of what you could deliver.
So I've been working on climate policy for the good part of 15 years now. Of those, for about 10 years, providing data on climate policy to a wide range of actors, mainly parliamentarians who wanted to make better laws, hold their governments to account, pass budgets. And they said, we don't actually have enough data. We don't know what we have on each other's books, and we can't learn from each other. So the LSE, where I was working at the time, was commissioned to aggregate all of the climate laws and policies globally. It was a long project, Climate Change Laws of the World, has a very wide readership. And in that, we discovered that many other people want climate policy data, because for policymaking, for holding policymakers to account, for tracking global progress, and for risk modeling, which is something that is incredibly important to investors, insurers, banks, and corporates, climate policy and understanding the climate policy landscape is absolutely important. And data was absent. And the best we can do was have libraries of PDFs where you had to open them and they were laws and policy, and you opened the document and you pressed control find subsidies and control find standard. And at the same time, something incredible was happening. You could Google anything. You could find anything that you wanted on the internet, but yet you couldn't find data on the most important topics. So I jumped ship, I left LSE, and I founded Climate Policy Radar, which marries this universe of data about climate laws and policies globally with the emerging ability to analyze large quantities of text, the world of AI, and especially large language models. So that's what we do.
So explain then the difference that AI makes in doing that. I mean, you've pretty well explained, we can imagine trawling data like that, but how quickly can AI get to grips with that sort of stuff?
So let's think about AI for a second, and let's break it down. Let's think about intelligence, actually. What is intelligence? Intelligence, I think if you look at the definition, it's the ability to acquire and apply knowledge and skill. So the acquisition of knowledge often looks like finding data, analyzing it, synthesizing it, at mass quantities, because the size of the problem that we're tackling with climate is, of course, a huge one. And the ability to collect and analyze data about it, that's the first part. The second part of it is applying that knowledge, and that is where decision-making comes in. Let's park that for a second, because that's a tricky one. But our ability to look very, very quickly at huge amounts of data is where AI can do the trick. Now, I'm not a missionary for blind use of AI, and I think we're going to potentially touch upon that later. But the ability to read huge amounts of text, to extract structure from it, to say, find me all the references to blue hydrogen in 700,000 pages of text, and show me where it comes with references to the just transition, and show me where it has impact on indigenous people. And please, while you're at it, translate it from every single language, because otherwise there was no way we would have read or have access to that data. And therefore, we wouldn't incorporate it into our decision making. And therefore, we would end up with the poor decisions that has been our share for a very long time.
So you ask the right questions, and how quickly do those answers come out? I mean, for instance, the translating, that would take humans a very long time.
You use Google Translate, I imagine, or other services, and the ability to do that at a button, as press of a button right now is incredible. There are still problems with auto translations. There are still the ability to capture accuracy and detail, and the way that different languages describe different terms is very different. But the ability to do so at mass means that we have a good head start into it. And what more, the places that weren't able to do that because they didn't have access to resources, because they couldn't pay consultants, translators, or researchers to do that for them, now have the ability to do that. Climate Policy Radar is a not-for-profit. We create public goods, so everything that we do is out in the open, and all of that data is accessible for free, so anyone can have access to that. And the inequalities that inequality in data access is part of the exacerbating factors for climate change, and it's a.
So where is AI currently then being used in delivering climate goals?
So again, let's think about a variety of climate goals. The ability to very quickly and very deeply collect, analyze, model quite a lot of data is being used in emission reduction. So Climate Trace is a coalition that uses satellite imagery in order to trace emissions at the plant level. So you can see exactly where emissions are generated. Open Climate Fix is another not-for-profit company that has solar tracking. So it predicts the cloud coverage at a 5-minute interval. So you could actually optimize how renewables are being brought onto the grid, which allows us to offload fossil fuels from the grid and mitigate that risk of, actually, is the sun going to shine, and can I really turn off my diesel generator or my coal power plant, because I'm not really sure. So the ability to do that. Plastic pollution is mapped from space now. The ocean floor is being mapped. Extreme weather events and climatic trends are being mapped. So the ability to put solutions on problems and the ability to seam them next to each other is increasing, and really remarkable efforts, and we're kind of just starting.
So how important a role do you think AI will play in mitigating climate change?
It already is, because previously we just weren't able to do that. And previously, and the way that humanity works is that when you don't know something, then you prefer staying with in your comfort zone and not make a decision. And the more information we collect, the more likely it is that we will actually act on these issues. So when you model a certain physical risk, what is the chance that a hurricane is going to hit this coast in the next 5 years, 5 months, 5 days? The ability to do that, to prepare, to mitigate the risk, to anything from call the cattle in, to building insurance mechanisms that allow people to reduce the risk and reduce the impact, are actually really incredible tools in mitigating climate risk and climate effects.
So let's go to the fears then, because you've laid out very clearly the upside of AI for climate policy. There are so many fears that it is a Frankenstein-type development, humanity creating a monster that can potentially lead to our own downfall. We heard the godfather, the so-called godfather of AI, saying as far as he's concerned, it's a more existential threat now than climate change. How do you respond to that?
First of all, humanity is doing a pretty good job at destroying itself already without AI. If we think about climate change and the biodiversity crises, we see how humanity itself has created this for itself. I bring you back to the question of what intelligence and artificial intelligence are. And that is, on one hand, we talked about data collection and modeling and the ability to do that very quickly. And then on the other hand, we have the decision making. And this is where a line needs to be drawn, and we need to figure out how to draw it. This debate is very much alive. I don't claim to have any monopoly on any wisdom. This is moving fast. Big discussions are being had. But let's lay out the risks. The first risk is that we hand over decisions that have huge risks, huge impacts. I think Sam Altman, the OpenAI CEO, was asked at the congressional hearing about a week ago, can an AI-driven drone select its own target and then attack it? And the answer is yes, of course it can. And then we ask ourselves, are we willing to hand over that ethical decision, which has nothing to do with the data? The data can be, so if you open your Google Maps, for example, AI will tell you beautifully what is the shortest route, or what is the fastest route, or what is the lowest emission route, or what is the way that is accessible to wheelchair users. But only you can decide which one of those is preferable to you. And If you chose the fastest route and you would drive in your self-driving car and a child jumped in front, would you stop? That's an ethical question. Is the model optimized for making decisions that go in a certain way, or are there moments along that way that we say, oi, can you stop? This is not where I wanted, this is not. And those are ethical decisions. If we want, for example, to maximize the reduction of emissions as quickly as possible, sounds like a wonderful trajectory, right? And we could say, let's create policies or let's create technologies that do that. Are we willing to do that at the risk of displacing large populations because we want to build solar farms where there are villages, or we want to move a river away, or we want to do other things? Those are ethical decisions. Those are decisions that don't have a right or wrong answer. I mean, I could have my opinions, but other people can have theirs. And whether we hand that over, and what is it that we tell the machine to optimize, what is it that we tell the machine that it needs to calculate for, that is something that we need to make sure that remains a human decision. Now, that's the number one risk, and that is handing over decisions. And that is something that governance over that is important. One of the more kind of one of the, I'll call it a simpler risk, is that a model is only as good as the data that you put into it. The choosing of that data and the potential biases on that data are two of those risks. So if I train a language model to detect, I don't know, subsidies or climate change or indigenous peoples, and I train it on English language texts from the global north, but those texts or those concepts are represented completely differently in the global south. And then I say, is Angola doing X, Y, Z? And the large language model says, no, it doesn't. But maybe Angola is doing it, but actually talking about it differently. If we do not acknowledge the bias risk and make an active effort to reduce it, make an active effort to protect our data, to make sure that the data that we use to train our models is real, is integral, isn't polluted, isn't attacked by malware, isn't attacked by other malicious intent. Those are things that can completely pollute our models. The choice of the data will tell us the results. So choosing it carefully and protecting it are two of those risks.
Are you worried, though, about the scope for how it could go wrong? I mean, what you're talking about obviously is extremely careful, intelligent use of AI, but there's no guarantee that everybody's going to be signed up to that.
I'm incredibly worried, but I am an intentional optimist. And optimism doesn't mean that, for me, optimism doesn't mean that you calculate objectively what is the chance that something will go right or wrong, but it is saying this has the opportunity or this has the potential to go right if we do X, Y, Z. So there's quite a lot of safeguards that we can put in order to control this game-changing, world-changing, ecosystem-changing technology. And we've done quite a good job at doing things like governing new technologies. The biochemistry industry, the medicine industry, the medical industry is one of those where we have identified the risks and created governance mechanisms that are far from perfect. But today, you know what it takes to develop a medicine or vaccination, and what governance mechanisms are there, and who needs to sign it off, and there's recall, and there's tests, and there's documentation, and there's intellectual property, which is very messy, and maybe that's one of the things that we need to change as soon as possible. But there are ways in which we can govern technologies that we perceive as great risks. And I think the conversation now with AI, which features, by the way, the large actors that are creating this technology, or that are the forefront or the leaders of creating these technologies, are calling upon themselves to be regulated, which is interesting, and we can be cynical about it, but we can also just regulate. We don't have to only be cynical about it and say, well, if they're saying it, then we shouldn't regulate them, right? Let's regulate anyway.
But as someone working in that space, you'd ask the policymakers to regulate as well, would you?
Absolutely. Now, I think that it's important to remember that the power now is concentrated in the hands of few who hold large black box models. And those large black box models are dangerous in that sense because they are not subject to governance. You do not know why you get certain answers when you type your questions into ChatGPT. And I'm not singling them out. There's other black box models, but they're the ones that we all seem to kind of to know and recognize now. And while the power is concentrated in the hand of the few, we need to do two things. One, make sure that we have the parallel open source models, the ones that are not black box. And I'm thrilled to discover that the speed at which the open source models are catching up is beating all the predictions. We used to think that it would take 4 or 5 years of coming up to the same quality and to the same speed, and it would cost a great amount of money. But the open source models are really starting to bite the heels of the closed proprietary models, and that is very promising. It is not enough because we need to put governance around the usage of that and the usage of data. And we need to flag the risks, we need to acknowledge them, we need to signpost them. You need to know if what you got is from an AI or from a human. Mm-hmm. And you need to know what is it that allowed you to make your decision so you can actually choose for yourself and not it be imposed on you.
And that's very basic, and right now we don't know when we're looking at stuff online, do we?
Not enough yet.
No. Yes. Just to let you know, if you're sending in questions, there's a technical issue going on, so I can't currently access them. I'm hoping it'll resolve and I'll be able to put some of your questions to Michael, but do keep sending them in the hope that the system gets back up and running, that the QR code is there on the wall for you to do that. I talked about the energy consumption of the machines themselves. How much of a thing is that when we're looking at, obviously trying to do good, for climate change, but the unintended flip side of it?
Sure. So AI does consume a lot of compute power. It is getting more efficient. AI itself is making it is enabling its own efficiency because it allows thinking about I'm blacking out on a word. It happens on stage sometimes. I will remember the word in a minute and then I'll finish my sentence. But the ability to model and predict the energy use from the compute allows us to do this well. Yeah. Not well, but better, right? Yeah. And as everything, we need to ask ourselves, how much is this upfront investment in creating these technologies that allow us to then apply them in multiple places? How much of this is a net gain? So I would really be happy to be able to continue using these large language models and satellite imagery and deep tracking of the ocean floor. And I think that the price is going to be a fraction of the benefit.
I mean, some would describe the situation that we're in as effectively being like a technological arms race with potentially enormous risks. What about going the other way and just simplifying?
Good luck. I think we could ask that question about any technology. We could ask the same question about the Industrial Revolution or the internet or electricity. And ask, okay, the technology's out there, the genie's out of the bottle. Do we really want to stuff it back in the bottle? And even if we wanted to, can we? And I think that we cannot. That is my assessment right now, that we cannot. And also that we maybe don't want to. We have created some serious problems for ourselves that potentially this technology can help reverse. Can we do this in a safe way? This is the right time to ask these questions. I'm really happy we're talking about it. I'm really happy that everyone is here and listening and hopefully integrating this into your own decision making. I'm sure many of the people in the audience either are using AI at work or for their personal uses. And the way that we think about it, the way that we demand it to be governed and regulated, the way that we as citizens expect to be informed about it is an absolute critical element in being able to do this well.
I'm not able to get the system up. I don't know if anybody in the audience, I'm sure you've all got lots of questions, so if anybody wants to ask a question, you could put your hand up and we can do it that way. No, it's always harder to put your hand up and do it that way. So in that case, we've come to the moment then where I give you the magic wand, Michal.
Exciting.
If you wanted to see, yes, and you can use it for as many wishes as you'd like. But if you could wave it and see change today, what would it be?
So I think that climate change is a collective action problem. And I think that the one thing that is needed in order to solve those collective action problems is public goods. And I would like to see AI being used as a public good. The ability to track emissions, the ability to reduce emissions, the ability to look at policy documents and read them quickly and be able to make decisions based on those, all of that should be knowledge that is in the public domain. That will enable us to innovate faster, because we don't have time to wait until somebody, until some patent runs out, or until IP regimes allow us to do that. Recognizing that with proprietary regimes, there is sometimes an incentive to block innovation. Recognizing that public goods allow the reduction of inequalities, and recognizing that public goods, or open models and open data in this case, allow very quickly for the acknowledgement and the reduction of bias in the data. If we put out our models and our data sets, which we do on GitHub, and say, this is it. This is how we identify these concepts in the laws. This is how we say, these are subsidies on hydrogen. All of you can go and look and can say, actually, you're not doing it right. You missed this. You misrepresented that. Can you fix it, please? Or I'm going to take it and I'm going to fix it. The ability to mitigate that, the huge risk of bias, comes with the public goods and with the open source and the open data approach. That is an approach that is not easy to apply, because public goods need public funds. And we all know what public funding looks like when you start draining it. And we all know what wonders can happen when you give public funds to things like the NHS, and how much we don't want things like public goods like that in private hands. These are exactly the places that we would like to see. So my magic wand is being used for open sourcing all of the large language models and all of the applications of AI.
Fantastic. Thank you very much indeed.
Thank you so much.
Michal Nachmany. Thank you.
Thank you.
Thank you.
Thanks a lot.